A GATE 2016 question involving a steady flow device nozzle is solved. The problem statement is given as steam at an initial enthalpy of 100 kilojoules per kilogram and inlet velocity of 100 meter per second enters an insulated horizontal nozzle. It leaves the nozzle at 200 meter per second. The exit enthalpy in kilojoules per kilogram is. The schematic is given here. So this is the nozzle. Steam enters and steam leaves. It is given the nozzle is insulated, therefore the insulation. It is a steady flow device, meaning there is no accumulation of mass inside it during the steam flow. The data given are enthalpy at the inlet, velocity at the inlet, velocity at the exit, and we need to find the exit enthalpy denoted by the symbol H suffix 2. Nozzle is a device which increases the velocity of the fluid flowing through it. Compare the velocities: 100 initial, final is 200. So there is an increase. And in this problem, we need to find the final enthalpy at which the steam leaves. Initial enthalpy is 100 kilojoules per kilogram. So what change the enthalpy has undergone when it flows through the device? Solution is, since it is a steady flow device, we can apply steady flow energy equation, and that equation is, in a nozzle there is no work done. Since it is insulated, Q is 0. No data of height is given, and hence the potential energy term can also be neglected. Therefore, we can cancel this term, this term, this term, and this term. Our aim is to find out H2. We need the answer in kilojoules per kilogram, meaning mass is 1 kg. We don't consider here. And this yields H2 is equal to H1 plus half C1 square minus C2 square. All the values are given, substitute. H1 is 100, C1 is 100, C2 is 200, 1 by 2, and there is a 10 power 3. Why this 10 power 3? In order to explain, consider the formula for kinetic energy. It is half mc square. Substitute the units. Mass is kilogram, c is velocity, therefore meter per second whole square. This can be written as kilogram meter square per second square. This can be rewritten as kilogram meter multiplied by meter divided by second square. And in this, kilogram meter per second square can be written as Newton. Kilogram meter per second square is 1 Newton. And this yields Newton meter, and 1 Newton meter is equal to joules. Therefore, in kinetic energy equation, if you substitute mass in kilogram and velocity in meter per second, we get the unit of energy, that is kinetic energy, as joules. Now, look at this equation. We have H1 enthalpy and the kinetic energy term. Enthalpy H1 is in kilojoules per kilogram, but when you substitute the mass 1 kg and velocity in meter per second, the unit is joules. We cannot add a kilojoules with the joules. To convert this joules into kilojoules, it is divided by 10 power 3. On calculation, it yields H2 equal to 85 kilojoules per kilogram.